So yeah, today we have two really awesome speakers. We have Sven and we have Louis. The first of the two speakers today will be Sven. So Sven is the co-founder and CEO of Webiny Serverless CMS. He's worked with some of the largest media and e-commerce brands across Europe as their sort of trusted advisor on the topics of web performance and serverless architecture. Certainly got a proven track record in delivering results in multi-million-pound companies and multi-million-pound projects, and I believe he has acted as a CTO to 4 or 5 startups over the last couple of years as well. So without further ado, I would like to pass you on to Sven.
Cool. So in my talk today, I'm going to talk to you about Webiny, which is a CMS and an open source framework for building serverless applications. But before I dive into what Webiny is, I want to just briefly talk to you about what serverless is and why you should think about actually using serverless to build your next project on. Some of the key benefits of serverless are that, first of all, you consume services. There's no service to manage. In a way, if you have a database, you interact with that database via an API. If you want to do a read or a write, you send an API call to it, but you don't need to manage the underlying infrastructure there. Because you don't manage that, you also get a lot of time back that you can reinvest into building new applications, adding new features, instead of managing infrastructure, network, backups for it and stuff like that. But also many of the services, like the database or function as a service, they have a slightly different business model or a pricing model than what you've used to when it comes to like common virtual machines. With virtual machines, you pay them by the hour, regardless if you utilize them or not. But with serverless and services that are usually part of the serverless portfolio, you pay per request. So if there's no requests, if you're not consuming that service at that point in time, you don't pay for it. But then if there's a spike, you're going to pay for that spike. Essentially, you have a 100% utilization of the resource based on how much you're paying. In a way, you stop paying for stuff you don't use. Again, like with serverless, there's often a notion that you build things faster, and you truly do, because you spend less time dealing with infrastructure. If you want to get an application up and running, you don't need to get a server up and running first. You literally write some code, deploy it, and it's there. And scalability is often quite a challenging thing to do for larger projects. You have to think about load balancers, the networking, and many other aspects there to do it properly. But with serverless, often because you don't see the infrastructure and the infrastructure is managed by a cloud provider, scalability is a feature that comes built into those services. So it just works, it's there, and you don't need to deal with it. And when you think about these 4 benefits as one thing, there's a lot of stuff there that can help you achieve and build great products that you don't need to worry about scale. They have much greater resiliency than if you would to run it on your own infrastructure. And because of that, many big companies and organizations are seeing those benefits, from cost savings to faster product iteration life cycles. They're seeing those benefits and they are adopting serverless. Enterprises like Coca-Cola, Netflix, and many others are taking the serverless approach. But in an essence, if we need to summarize what serverless is, well, it allows us developers to spend less time worrying about infrastructure and more time on solving actual business problems. We actually are spending more time on things that our employers are paying us to do and not just managing servers. However, there are many challenges in when it comes to adopting serverless. Serverless is not easy. People underestimate what it's needed to adopt serverless and build solutions on top of serverless infrastructure. Here on this slide, like, you will see three groups of questions and answers. Like these were extracted from a survey on 1,500 organizations, and the survey was done by O'Reilly, and it was about serverless. There was a couple of different questions there, but I've extracted the top three questions. The first one being like, what are the biggest challenges why your organization hasn't adopted serverless? The top three questions, number one was security concerns, and the second was fear of the unknown. Like if you take these two into account, like as one group, like you can't secure something you don't understand, right? So that's why security concerns are a big problem. A lot of people don't understand how serverless works, or they do understand it, but with serverless, there's hundreds of different moving pieces when it comes to infrastructure. Unlike your traditional one where you have one server and then it's just horizontally scaled and everything that moves is mostly inside that server, or you have database and a caching server somewhere aside. But with serverless, there's hundreds of these little pieces, and it's hard to then know what the patterns are to put a proper security fence around it. On the second question, like what are the challenges, or when the organization has adopted serverless, so what are the challenges afterwards? Usually what we see is that adoption in larger organizations comes from a small pocket of engineers. It's not a company-wide adoption. It's this set of 5 engineers has adopted serverless and built the project using serverless infrastructure. But then how do you scale this across the organization, across hundreds or thousands of engineers? How do you educate all that stuff on serverless? And that's where they start breaking down and having problems. They don't have the materials. They don't have the proper tutorials, education materials, and many other bits for their staff to get up to speed on serverless. Now, the second bit is the vendor lock-in. Serverless services are often sticky and very sticky. So people are afraid that if they build something on GCP or AWS, they won't be able to move away. And in most cases, that's actually true. You won't be able to move away unless you actually re-architect your application. And thirdly, it's hard to test and debug. Out of the box, yes, because you have so many different moving pieces, it is hard to test and debug your applications. But there are different approaches to that, from using solutions like Lumigo or similar ones to test-driven developments. They can help you with that. But often those practices are not embedded in those organizations from day one. They go through a learning path to get those implemented in the right way. And when it comes to actually building solutions, like the top 3 approaches, number one is custom tooling, and this answer by far had the most votes. When you think about Cloudflare, they actually don't help you build a solution, they help you host the serverless function, that's it. Serverless.com is essentially a serverless framework which allows you to manage code as infrastructure. So the underlying services that your application is going to consume, serverless framework can help you create those and have it in a definition file so that they get created automatically for you by their framework. But when it comes to actually building the application logic, it's custom tooling. Everybody is reinventing the wheel there. When they want to adopt serverless, they start building their custom tooling, custom implementation of routing or the API layer and things like that. At the end of the day, that custom tooling is, first of all, it's going to eat up many of the benefits that serverless provides, because they're going to invest a lot of time in building their custom tools before they actually start building their application. And secondly, they're gonna have to maintain that, and that's where they're gonna incur a big expense on the long term. So those 3 challenges, and like the state of the serverless ecosystem at the moment, it's quite hard actually for smaller and medium-sized organizations to adopt serverless, and for larger ones, it's hard to scale it when they do adopt it. So with that in mind, like this is actually where Webiny comes in. So Webiny, first of all, is an open source framework for building solutions on top of the serverless infrastructure. And when you think about your application stack, illustrated here on the left, at the bottom of your stack, you have your infrastructure providers, so your cloud. They provide you with those services for function services, for database, and many others. And then on top of them, you usually use set of tools for deployment and monitoring. That can be Lumigo, that can be Serverless Framework, or many others. But in a way, these two, they don't help you build your serverless application. They help you host it and orchestrate it. But to build it, you need a foundation. That foundation is where Webiny comes in. Webiny provides you an API layer, a security layer, routing, file services, and many, many other solutions out of the box, upon which you just take them. They work out of the box as well. And then you just lay on your custom code, your business logic on top. And that's how you build your application. But by using Webiny, you don't need to spend all that time for custom tooling. All the tools you need are already there for you. When it comes to like the Webiny stack, so today Webiny runs on AWS, GCP and Azure are going to be available later down the line. But Webiny stack is pretty much 100% JavaScript. That's GraphQL for the API layer. Then we have TypeScript, Node, and Babel, Webpack, React. And in terms of databases, like Webiny today runs on MongoDB, but in the next month or so, DynamoDB support is coming. And later, towards the end of the year, we're going to be supporting MySQL, all the Aurora databases from MariaDB to Postgre, and many other SQL ones as well. So when you think, like, also just to mention, like, Webiny is completely free and open source. You just download it from our GitHub and you can start using it right away. And the mission we have at Webiny is to empower developers and organizations to create serverless applications. So that's it. We provide you with that tooling that you need. But it's more than just the tooling. So the Webiny comes with several parts attached to it. First, you're going to have a framework that helps you with the API layer, routing, and many other bits. Then there's an admin UI that you can use to build your interface for your applications. There's several ready-made applications that you can already use today. And finally, there's that documentation. I'm going to now jump into each of these to just kind of tell you a bit more about that. So under the framework comes in a couple of parts as well. So first, there's a command line interface. That interface is used to, first of all, create your projects, scaffold new APIs, deploy your projects. So you don't need to mess around with Lambdas, API gateways, and stuff like that inside AWS. Webiny automatically creates all that for you. Then the framework comes with a GraphQL API layer, which is powered by Apollo Federation. Apollo Federation actually plays a key role here because your services for your applications are going to be structured as microservices, which are going to then expose certain schema, parts of the schema. And then those parts actually get all glued together by the Apollo Federation, and one uniform schema is then sent out to the world where developers can interact with your application. But at the same time, as your application grows with more and more services, this approach works well because you can have hundreds of microservices without actually worrying about our architecture, worrying about if this can scale. With Webiny, that's an inherited feature. And then there's a lot more things under the hood there, from routing, server-side rendering, although it's more of a serverless side rendering because it's done inside the Lambda function, access control layers, CI/CD pipelines, file management, and many, many other bits. But that's the framework. Besides the framework, the mentioned admin UI, it's an interface that actually allows you to build additional applications on top of it by reusing a set of React components. There's like 30 or 40 of those. There's a storybook that's also public that you can use, and everything in the interface is a plugin. So from the menu, from the logo, from the search bar, from the drop down, all these are plugins which you can turn on and off, or override them and take over the control, or expand them by adding new plugins to it. So every single bit inside Webiny that you see, you can change. And there's also a dark mode for the people that prefer more of a dark interface. Now, when it comes to apps, as I mentioned, Webiny comes with several built-in apps. One of the apps there is a page builder. It allows you to essentially build landing pages with a drag and drop editor. It's got server-side rendering behind it. Everything runs on top of a serverless infrastructure, but it's also quite a powerful tool, because like the components here that you drag and drop are not static HTML. They're actually full functional React components. They can do API calls, they can have settings, they can contain business logic, things like that. We have people actually building business dashboards using this tool. So it's a really powerful one. It supports revisions and many other features behind the scene. Another app that comes built in with Webiny is a form builder. It's a drag and drop interface to build forms. Then there's like you can drag and drop inputs, radio buttons, checkboxes. You can add validations. You can add triggers, webhooks. There's a lot of features in the form builder. But as you build the form, then using the page builder, you can insert that form into specific pages. Another app is our file manager. People think like, oh, I'm going to build a serverless app, and for the file system, I'm just going to use S3, and that's me done. Actually, we found that it's way more complicated than just having an S3 bucket to manage files in a serverless environment. You have to manage who can upload what, who can read what, how do you resize images. There's a lot of more under the hood there that you need to think about. And we built this file manager, which is embedded into different existing apps inside Webiny, but you can use the file manager embedded in your own apps. And then you can upload images, many other files, resize them. There's an image editor that's built in. You can search for images, categorize them, and so on. You can upload images 10 or 100 gigabytes in size. It all works fine. And the final app that I'm going to mention is our headless CMS. So it's a full-on headless CMS with multiple environments, GraphQL API, ability to build your content models through a drag and drop interface. It's got revisions. It's got multi-language support. It supports references. So it's a full-on headless CMS that you can use. And we've got tutorials for Next.js, plain React, Gatsby. You can hook it into any system that you want. So besides the apps, the other more important bit is the documentation. We've put in a lot of effort, and we're still working quite a lot on producing more guides and more tutorials for Webiny. But the point of the documentation is to flatten that learning curve when it comes to both serverless as well as when it comes to Webiny. The documentation is both in written format, and there's a lot of also tutorials on our YouTube channel in a video format. And we've got a GitHub repository with many examples that you can use there. Is a way to kind of summarize this. And go back to that serverless challenges slide. If you think of the challenges there and then think about Webiny, like first of all, with Webiny, like the fear of the unknown goes away because everything is deterministic. There's patterns for how your application is going to grow, for how you're going to be adding new microservices, for how the files are going to be managed, for how the users are going to be interacting with it. So it's all documented, it's all deterministic, and based on that, you know how to put the proper security in place. So the first two challenges are sorted in a way. When it comes to challenges after you have adopted serverless, like scaling the knowledge, well, without documentation portal, everybody can go through a series of tutorials and build their knowledge on serverless, build their knowledge on Webiny, the best practices, and how to build applications. Vendor lock-in. So Webiny, although runs on AWS only today, Webiny has been built and architected from ground up so that it can run on other clouds as well. We just need to write the deployment mechanisms for them. But the logic that you write on top of Webiny once the multi-cloud cloud support comes, they're going to be able to migrate seamlessly off to other clouds. And when it comes to testing and debugging, we've got best practices documented there on how to approach that. We also have a plugin for Lumigo that you can use to help you out with integrating with Lumigo, but as well as some other third-party observability tools. And when it comes to building the server solutions for the need for custom tooling, well, it completely goes away. Webiny out of the box gives you pretty much all the tools you need. Everything is there, and if there's something missing, like we have a super active Slack community, the Webiny team is also engaging with members there. If something is missing, you just need to shout out, tell us what's missing, and we're gonna add it to the roadmap. So as a summary, like with Webiny, you can build more than just websites. You can build APIs, you can build full-blown applications and microservices. And that's pretty much it for me. So again, you can find Webiny on GitHub. It's fully open source with the MIT license. You can find also additional information on our website, and you can reach us on Twitter.
So, I mean, there's one that I wanted to run past you, which I just thought of sort of during the during your presentation, which is sort of what was the biggest challenge with the serverless infrastructure, and how did the pros of going in that direction outweigh the cons? I mean, I understand that you said that it was quite a journey to get to where you've got to. So what made this journey worth it?
Yeah. So, I mean, to put things in perspective, like our vision of the future is that everybody will adopt serverless, that serverless will be the standard of how all web applications are going to be built in the future. That's our vision, but that's also the vision that big cloud providers like AWS and others are pushing. Everything is going towards that direction. So we know that that's going to become a reality in the next few years. However, there's many challenges along the way. Serverless is still maturing as infrastructure. Like, for example, one of the biggest challenges for us was managing database connections. Traditional databases, the SQL ones, as well as MongoDB and things like that, the way how they manage connections, TCP connections between a client and the database, it's not, from an architectural standpoint, it's not good enough for a serverless environment. There's a big problem with zombie connections there, so we had to build our own connection pooling system, a lot of challenges there. There was also a lot of challenges when it comes to SEO. Serving files in general from a JavaScript doesn't work because crawlers can't read the content because they have to execute JavaScript. They don't do that. So there's the notion of server-side rendering. That works usually fine. But then how do you do server-side rendering in a serverless environment? The Lambdas behave differently. There's a problem of cold starts because you don't want to wait for Lambda to finish server-side render snapshots, which on a Lambda takes 5 to 6 seconds. How do you manage that? How do you offset that time? So there was a lot of challenges there that we had to go through, which were super specific to serverless environments. Managing files is another thing. Those challenges you don't think are there unless you start building a full stack application that has to perform on a big scale. So as we went through our notion of building Webiny, we were discovering those challenges. We didn't know what those challenges were until we actually hit that challenge, and then we had to tackle it. So the ones that I mentioned, many others, but like just by using Webiny, you kind of get rid of all those, and you just focus on your code.
So you made a lot of the difficult mistakes for these people in advance.
Yes, exactly that.
Kevin asked quite a good question as well. So can this be used along with Java in the Spring framework or Quarkus?
So no, unfortunately, Webiny is JavaScript only. So what you could do is install Webiny on one set of Lambdas and then consume the GraphQL API on the other bit and use the headless CMS to build the API and stuff like that. Because then the interaction happens on the API layer, which is technology agnostic. But if you wanted to add some functionality to Webiny, it's pretty much React and Node that is supported.
For sure. Okay. And then again, Philip in the Q&A was, is the serverless service free to some extent before payment? And secondly, does the page builder enable the use of custom templates and external DB connections?
So the serverless Webiny in general is free and open source. It's installed onto your own AWS cloud. So there's nothing that you need to pay to us. The cost is going to occur on your own AWS cloud, but the free tier is really generous. So you like for any tests, there's going to be no cost. And does the page builder enable the use of custom templates? Yes. How to build templates is fully documented on our documentation portal, but not just templates. You can actually build a page in the page builder and use an NPM package and integrate it in your own system to render the page. Technically, you can render it inside Gatsby and things like that. And does it allow external DB connections? Yes. So Webiny today runs on MongoDB, but that's where Webiny needs to install its stuff to work. But besides that, you can have parallel connections to Dynamo, to any SQL database, to any other database as well. Webiny doesn't restrict you to do that. However, like in the upcoming months, you will find that Webiny is going to add support for DynamoDB. So you won't need to use Mongo. You could use just Dynamo, but then down the line, all the SQL databases will be supported as well. So.
To be fair, I think that follows on quite nicely to Rajat asked. So you're saying that his DynamoDB writing cost goes outside of the free tier pretty quickly. He's sort of saying, how is it possible to monitor what is causing this, and what are the best ways to sort of control DynamoDB costing? I mean, I know that you just said that your model sits closer to MongoDB, but have you got any insight?
Yeah. So I mean, with DynamoDB, it's tricky. So Dynamo gives you performance, but at a big cost. And cost with Dynamo tends to go out of hand rather quickly. Things like having bulk writes and more intelligent reads helps drastically. For example, what we found with Webiny is that paginating stuff on DynamoDB, it's much cheaper to do on the client side. Read from Dynamo 1,000 records, display 10 to the client. And then when the client paginate on the client. Sorting also doesn't work on Dynamo. It can be rather tricky to do properly. Sort it on the client side. It's going to be cheaper. Make sure that the reads fit within the criteria where it says X kilobytes in one read is the limit. Make sure that your reads are optimized for that. So the amount of data that you pull back. You might need to cut down on some of the data richness inside the AP, inside the UI, to control the cost at the same time. That's what we're doing with Webiny at the moment. Is we're doing this transition from MongoDB to DynamoDB, and one of the biggest challenges there is not a technical one, but a budget one. Because if you do too many reads, the cost can get out of hand. So we're doing these tricks and best practices. How we learn those is the AWS console. How you control your AWS actually runs on DynamoDB, and check out the API calls. You will be surprised what API is returning and what you're seeing in the UI, how AWS is masking a lot of things on the client side, but reading a ton more stuff in bulk reads from the API because it's cheaper. So we were just inspecting how they did a lot of these things on their end, and we're just following those common patterns there, as well as the book from Alex Debris. Is a valuable resource I can recommend that has also some of the best practices on how to optimize the cost there as well.
It's really good to know. Thank you. There was one that I saw from, where did it go? It was from Brian, I believe, or Owen. It was basically saying, when will Webiny work with Azure, if ever? Do you have any plans for that?
So we do have it in our plans. It's on our public roadmap. So webiny.com/roadmap, the multi-cloud support. At the moment, the focus is pretty much on AWS, but all the code we write has this notion it's going to run on other cloud providers. It's more of writing the cloud adapters. However, we're in the process of migrating from a custom deployment mechanism to Pulumi. So we're going to be using Pulumi under the hood. Pulumi has already multi-cloud support. So by migrating to Pulumi, we're going to get closer to supporting Azure and GCP. But then there's going to be still some more work left there. We are looking for support from the community to help us with some of that. We already have several people working on GCP. They're checking in here and there and are doing some proof of concepts, and we are assisting them. So if you're interested in doing something for Azure, we can jump on our Slack and then kind of give you some reference points on where to start, and then show you support throughout that journey. But we as a core team, we're smallish, so we're focusing only on AWS at the moment.
But how would you go about getting health and diagnostic metrics of deployed services?
A CloudWatch primarily. And so there you can track the response times from Lambdas and things like that. So that's one way that you can use it out of the box. Another way would be to have a monitoring tool. Lumigo, New Relic, some of these you can embed and put inside your applications, and they can monitor services like Lambda and other services as well. So these are kind of the two approaches I would recommend.
Okay. And coming back to your, I think it was the image classification. So is there any integration with Cloudinary with Webiny?
So no, not at the moment, although we were asked that question a few times from the community. There's a way to add Cloudinary integration to Webiny so that the resizing can go through their API if you want to, but it would require building a custom plugin for that. So out of the box, no.
Okay, and this was actually another Webiny question as well. So Nuxt.js and Next.js are frameworks which enable Vue and React for server-side rendering. Do they integrate well with Webiny? I know that you mentioned that it was predominantly Node and React. So
when it comes to our headless CMS, you just consume the content via the API inside your Next app or Next.js app or any other system. When it comes to our page builder, if you want to render pages inside your, say, Next.js app, there is an NPM library that you can pull and then render it inside the Next.js app. And then it's up to you how you're going to handle the server-side rendering on Next.js. Next.js provides an out-of-the-box integration with Vercel. That can work fine. So, but if you want to build something inside the Webiny admin, that's React only. But for that, you don't need server-side render because it's a backend. You don't need it there. So.
Okay, cool. And Sven, coming back to you, so is there any enterprise support for Webiny, and can they deploy? Can we deploy services which need PCI compliance using Webiny?
Yes. To both questions. For details, just go to our site and there's a book a call button there. There's a lot of detail to be discussed there, but in general, yes. Because Webiny is self-hosted, we can work with your team to get the PCI compliance going on top of Webiny inside your own cloud.
Okay. And can you use Gatsby or a Jamstack approach?
Yes, so on our documentation portal, we've got tutorials for Gatsby, we've got tutorials for same Next.js, Vue, even how to use Webiny with React Native and build an Android app. So we've got all those tutorials on our documentation site. Jamstack works fine. Webiny is hosted on AWS, but the front end with Gatsby can be hosted on Netlify or whatever you want. So.